What is operational technology, OT, and how does it differ from information technology? How is U.S. Air Force pursuing a control system cyber resiliency program? And what can be done to elevate the importance of OT cybersecurity? I'll explore these questions and so much more with my very special guest, Daryl Haegley, Technical Director, Control System Cyber Resiliency at the U.S. Department of the Air Force. Could you tell us more about the role as a technical director? What is a technical director in the context of the portfolio you're under your charge? And who do you report to in the department?
Well, my position physically resides in the Air Staff A4 Logistics, Engineering, and Force Protection, then within the Director of Civil Engineers A4C. But my role is broader than these, and I have a great partnership with the Chief Information Security Officer on the Secretariat side. Since the CISO oversees cyber policy and execution across the department, I've integrated control systems into that portfolio, which typically has yet to include them. A key task I have is to oversee the progress on the Department of the Air Force strategic plan for the control systems and its associated implementation plan. And it was published in 2021, signed by the Air Force CIO, and it's developed across all the functional communities to be a 10-plus year roadmap with 4 lines of effort to address pervasive capability gaps in how we organize, train, and equip our forces for the cyberspace fight demanded by the National Defense Strategy. So line of effort 1, develop organizational constructs and cross-functional complementary workforce. The people who do the IT stuff are not going to do the OT stuff, and the civil engineers are not trained in cyber either. So there's an opportunity there. Line of effort 2, identification of critical control systems and the DAF-wide portfolio visibility. So, there are a number of different systems, from those that support logistics, to depots, medical systems, the nuclear facilities, making sure that we know which systems support which missions, and then understanding the information from those and how do we get them to the right cyber professionals. Line of effort 3, ensuring cyber resilient control systems across their life cycle. I'll explain a little bit later how they are not secure by design and how we need to make sure our contract language includes cyber into these systems, and that we have a good way of identifying, detect, protect, respond, and recover through that whole process. And the line of effort 4, establishing an agile cyberspace defense and recovery through real-time continuous monitoring, incident detection, coordinated response, and readiness. So essentially that whole process and how we get it from a system owner when they detect something out to a cyber defender to respond, and getting it up to the highest level of coordination. So our desired end state: control systems, operational technology are cyber resilient and defended to assure our missions. The scope for these owned, operated, and acquired systems by the department and associated components, devices, and networks, and applications and data. So the whole aspect from what's in the system, where this data resides, and how to protect it. So, for example, water and power distribution, intrusion detection systems, fire suppression systems, airfield lighting, material handling, industrial, and even nuclear. So there are over 100 tasks that we're tracking over the next several years, and as we make progress, we will be best positioned to identify, protect, respond, and recover from adversary exploitation.
Yeah, given all that, wow. I'm thinking about your responsibilities, Daryl. I was wondering if you could outline for us the most pressing management and, say, operational challenges that you face in your current position, and maybe you can glean a little insight into what you've done to address those challenges.
Well, I'd like to provide some history on how I got here. So 10 years ago, DoD had no security focus at all in this space. The department had purchased tens of thousands of smart meters, and the energy managers wanted to connect them to the building OT networks. The IT and cyber experts said, no way, because they had no built-in security. And that issue made its way to the headquarters level, where I sat, and we learned that there were no OT-focused policies, procedures, or resources. And since then, we've made much progress in changing all of those, and the taxpayers rest assured those unused meters are stored securely in the warehouse next to the Ark of the Covenant. In 2016, we created cybersecurity-related unified facilities criteria for when we build new buildings and structures to be applied to DoD's 500 installations, 4,000 sites, 250,000 buildings and 400,000 structures, as almost all have OT that provides continuous communication. And for years, critical infrastructure was considered only outside the base. And in DoD, we struggled to determine who would cybersecure the on-base OT. That is changing. And everyone should realize that 100% of DoD's OT is the same as the OT that industry uses outside the base. Congress wanted to know that we had assessed our on-base defense critical infrastructure, in which all our missions depend, via 2017 National Defense Authorization Act. So we assessed our bases from a cyber lens and have a list of many vulnerabilities we are mitigating. And all of us know adversaries target these easy, non-secure targets. I recall a classified brief in where several DoD executives were detailed on how nation-states are exploiting OT. And at the end, I asked the briefer, what are the chances of detecting an adversary presence on our OT networks if we have zero tools and no skilled experts to discover their presence? And of course, the briefer looked at me like I was a donkey with a high IQ and said, zero? And my question was not that I didn't know the answer, but I wanted the execs to hear that from the threat expert, because I would hear from the execs routinely, Daryl, our OT always worked, so we don't see a problem. Our stuff must not be that critical since we have yet to have a cyber incident. Or none of these are really critical because we can go into manual mode. And affirming that briefing, the Director of National Intelligence published an unclassified report in 21, 22, and 23 that all reiterate China, Russia, and Iran, and North Korea are actively targeting our critical infrastructure. In 2022, Congress in NDA 1505 asked the Department to let them know that we have mapped our OT networks to our most critical assets and that we are funding the cyber hardening of them in future years. As everyone knows, you can't ask for resources if there's no requirement, and that helped us get there. But we recently developed a control system cyber defense reference architecture called Mosaics, or More Situational Awareness and Control Systems, a framework that enables industry to provide capabilities aligned to any one or all of identified detect, protect, respond, and recover functions. In May 2021, the President signed an executive order on improving the nation's cybersecurity, specifying that cyber protections will be applied to IT and OT. That's the first time that was ever focused at this presidential level. Subsequent to the presidential memo in January 2022, the National Security Manager Memorandum on Improving Cybersecurity of National Security, DoD and Intelligence Community Systems, for the first time, not only just intelligence systems can now be classified as a national security system. So that would now get the attention and support. So all of this helps to inform leadership that these systems are critical and need resources.
What is operational technology, OT, and how does it differ from information technology?
We probably should have started by having your listeners have a little bingo card with all the different terms that apply here. There just are many, and I've come to use operational technology or control systems. A new one is that's been also promoted by the National Institute of Science and Technology is cyber physical systems. And they seem to be interchangeable. So operational technology is defined as control systems or controllers, communication architectures, and user interfaces that monitor or control infrastructure and equipment operating in various environments, such as weapon systems, utility or energy production, distribution, medical, logistics, nuclear, biological, chemical, or manufacturing. So, a pump, a motor, a thermostat, different devices that take an input and then make something else happen. Control systems, as defined as a system in which deliberate guidance or manipulation is used to achieve a prescribed value for a variable. So control systems include the supervised control and data acquisition, or SCADA, which are the very large power plants. We've also got distributed control systems and program logic controllers. Again, these things are all on the walls, the ceilings, that take a sensor and then send a signal to make something happen. Cyber physical systems, interacting digital, analog, physical, and human components engineered for function through integrated physics and logic. I don't know. So it seems like a whole, a fancy way of saying what the first two said, but it does not only just apply to digital and things that are up to date. So it can happen at the analog level. I think one of the most important characteristics is to understand the confidentiality, integrity, and availability, or CIA triad, which is a common model that forms the basis of the development of security systems used for finding vulnerabilities and methods for creating solutions in this space. Confidentiality has to do with keeping an organization's data private. This often means that only authorized users and processes should be able to access or modify the data. Integrity means that the data can be trusted. It should be maintained in a correct state, kept so that it cannot be tampered with, and should be correct, authentic, and reliable. But just as important, that unauthorized users are kept out from an organization data. Data should be available to authorized users whenever they require it. This means keeping systems, networks, and devices up and running. So for OT, availability is most important. What's clearly different is information technology, or IT. So it is the use of computers to create, process, store, and retrieve and exchange all kinds of data information. So your laptop, printer, phone, etc. So within that CIA model, for IT, confidentiality or integrity is most important. So that's really where the differential is.
I was wondering if you could share with us, Daryl, your strategic vision for control system cyber resiliency across the department, and what are some of your key priorities that you're focused on?
Well, to mitigate these ever-present threats, you've got to have policy put in place to make sure that people know what to do. And if there's policy, you can ask for money. So we've hosted regular service and agency collaboration meetings. It's just critically important that we all are aligned as best as possible. We've hosted government industry events to learn the latest capabilities in this area. We've spent the last 5 years connecting the energy management control systems on all 140 bases to a secure network. And while that's important, it only represents a fraction of all the control systems in the department. Perhaps most important is to get this message clear to the airmen and guardians in the field, as each of them play a vital role in ensuring that our department is resilient in cyber contested environments. Utilizing the right tools and techniques to prevent our adversaries from impacting our operators starts with 3 actions. Updating emergency response checklists and recovery plans to include cybersecurity considerations. Conducting regular rehearsals of your roles to recover and ensure the mission. Knowing who to contact for assistance can be the difference between success and failure to countering a cyber attack. And then contact my office or their squadron's security manager to learn about best practices and understanding their role in cybersecurity and requesting resource advocacy. We see a lot, time and time again, folks are just not even asking for what they need. We've estimated it will take about $2 billion to make substantial changes and progress in mitigating our top vulnerabilities and implementing the control system strategy implementation plan.
What are some of the key challenges of securing OT systems against threats that emerge from the IT network connections? And what can be done to identify emerging approaches that can increase OT resiliency in the face of these threats?
Right. So there's several ways to go after that. So first is interconnectivity. So with the integration of IT components on these OT systems, it introduces that wider attack surface, as vulnerabilities in the IT environment can be exploited to target these systems. We found where you can go in through an OT system back into the IT system and vice versa. So, and the other thing we found is people who are on a list to access OT systems also have access to IT, or the other way. So just getting to your access list would be something to take care of. Operational impact. OT systems are designed to ensure uninterrupted operation of critical infrastructure. Applying security measures, such as patches and updates, can introduce downtime or affect the performance and reliability of these systems. And we've often asked, hey, well, Commander, what we want to do is we want to see if we can hack into this system. Well, nobody wants their system to go down, so that has yet to really happen. Mm-hmm. But to identify emergency approaches that can increase OT resiliency, several strategies are being adopted. We're doing risk assessments, conducting thorough review to identify vulnerabilities and attack vectors. Threat intelligence and information sharing. Engage in the distribution and leverage sources specific to OT environments. And this can help with identifying emergency attack techniques and vulnerabilities, enabling proactive measures to enhance OT resiliency. The intelligence community has been so focused on the IT side, they're just now getting aware of the OT side. Sensing. We've got to have real-time visibility, monitoring, detection capabilities across systems. And, that's the next kind of playing field in which we're focused on.
I was wondering, what are some of the key operational technology risks that can impact supply chain resiliency?
Yeah, so supply chain resiliency can be impacted by various operational risks that can disrupt the flow of goods, services, or information within the supply chain. Some key risks are, the disruptions, demand volatility, inventory management, quality control, product issues, technology system failures. We've asked vendors to give us their, bill of materials or essentially all the things that are part of their systems and software. And, some of them are excited about sharing that and some are not because, a lot of that is their special sauce. Across a installation, there are many different types of systems that have not been fully vetted through supply chain risk. So we're just beginning to start collecting that data and determine, where the sources of, our systems are, are the products of those systems. It's policy to not buy anything, that's made in China. And so we're working on different ways to figure out, where those sources are.
So given your background and your current role, and I know this is kind of a long way out, but where do you see the government industry going in this field in the next 5 to 10 years?
Well, for those playing bingo at home, you're going to hear it now, zero trust, right? So there's a lot of focus on DoD and industry on the concept of zero trust. It is essentially the most basic concept is assuming that bad actors are already in and data is new in the perimeter and don't inherently trust it. You need to verify it. This model is more data-centric and emphasizes resiliency. Control system teams might transition some operational functions to cloud-based services. Industrial processes such as water treatment or electricity generation may or may not follow this path, but hardware virtualization, we believe organizations are increasing their flexibility in how they deploy the assets that manage and control these processes. So many vendors offer capabilities to implement zero trust, as well as artificial intelligence. It's pretty easy to monitor the thermostat temperature, right? That should not deviate too much. But the onus is on us to determine a fair way to evaluate those options in DoD representative OT environments. I think in the next several years, OT training will become more relevant as college and universities begin to include it and cross-train both. Optimally, we will share more threat and solution data amongst government and industry will continue to build security into their products from the beginning.
This has been the Business of Government Hour, a conversation with Daryl Haegley, Technical Director, Control Systems Cyber Resiliency at the U.S. Department of the Air Force. Be sure to join us next time for another informative, insightful, and in-depth conversation on improving government leadership and its effectiveness. Until then, subscribe, download, and listen to the entire interview at iTunes, Spotify, or on your favorite podcast app, and as always at businessofgovernment.org.